With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question it is said that calculate the molar conductivity of HCOOH at infinite dilution if equivalent conductivity of H2SO4 is X1, Al2SO4 whole thrice is X2 and HCOO whole thrice Al is X3. Right? So these are the things given. First of all, let's discuss this important formula that the equivalent conductivity is given by equivalent conductivity is equal to 1 divided by the number of cations into the charge of cation whole multiplied by its molar conductivity. This is the most important relation, that equivalent conductivity is equal to 1 divided by the charge on cation into the number of cation whole multiplied by the molar conductivity. Now our job is to write down the equation of each of these compounds. Like for H2SO4, which on dissociation will form 2H plus SO4 2 minus, right? This is the H2SO4 dissociation. Then on Al2SO4 whole thrice, this on dissociation will form 2Al3 plus 3SO4 2 minus, right? And HCOO whole thrice, Al on dissociation will form 3HCOO minus plus Al3 plus, right? This is the three important equation. Now our aim is to calculate the that is the equivalent conductivity of this HCOOH at infinite dilution. We need to calculate the molar conductivity if the equivalent conductivity is given, right? So first of all, let's number these equations. This is equation 1, this is equation 2, and this is equation 3, right? Now what we need to do, we will write down the molar conductivity for each of these equations. So let's write down the molar conductivity of equation 1 can be written as n number of cation into the charge of cation whole multiplied by its equivalent conductivity, right? From this relation we can write down the molar conductivity is this. So from here, in the first case, you can see the number of H plus is 2, the charge on H plus is 1. So finally this is 2 times of equivalent conductivity, right? This is the first case. So or you can write down 2 times of x1, right? For the H2SO4, the equivalent conductivity was at x1, so you can write it down 2 times of x1. So this we have calculated the molar conductivity of 1. Now let's calculate the molar conductivity of equation 2. This is again n plus into z plus into the equivalent conductivity of equation 2. So from here you can write down, see how many number of cation? 2. So 2 is the number of cation and charge on cation is 3, Al3 plus multiplied by equivalent conductivity of 2. So this can be written as 6 times of x2, right? We can write it down as 6 times of x2 since x2 was the equivalent conductivity of Al2SO4 whole thrice. So this can be written as 6 times of x2. Now let's calculate for molar conductivity of equation 3. This can be written again as n plus into z plus into the equivalent conductivity of 3. So what is the number of cation in the third part? You have only one cation and 3 is the charge. So 1 into 3 whole multiplied by the equivalent conductivity of 3. So finally you can say this is 3x3, right? So we have calculated the molar conductivity of equation 3, the molar conductivity of equation 2 and the molar conductivity of equation 1. So we have calculated all these three things. Now let's calculate the equation for HCOOH. So for calculating this equation for HCOOH, what we can do, we have to multiply in order to make this SO4 2 minus similar to the second equation, multiply the first equation by 3. So multiply equation 1 by 3 and equation 3 by 2. So this was equation 3. So if you will multiply it with 2, then what will happen? 2al3 will come, and in the second equation already 2al3 is there. So when we will subtract it, it will get cancelled. So first of all, we have to multiply the equation 1 by 3 and equation 3 by 2. So let's multiply it. In the first equation it is H2SO4. So it will be 3H2SO4 giving you 6H plus 3SO4 2 minus. This is the first equation which is multiplied by 3. So let's name it equation number 4 now. Now the next equation we can write down like this. The third equation, if it is multiplied by 2, HCOO whole thrice Al, this was the third equation. If it is multiplied by 2, so it will be 2HCOO whole thrice Al. It will give you how many? 6H plus again. Right? No, it will give you what? It will give you 6HCOO minus, right? It will give you 6HCOO minus plus, on multiplying it you will get 2Al3 plus, right? Now what you need to do, you need to add both of these equations. Add equation 4 and equation 5, and then what you need to do, you need to subtract it from equation number, you have to subtract it from equation number 2. So we will do that in detail. So first of all, you need to add the 4 and 5th equation. So let's add it. So it will be 3H2SO4 plus 2HCOO whole thrice Al will give you what? 6H plus 6HCOO minus plus 3SO4 2 minus plus 2Al3 plus, right? This is the addition of 4 and 5 equation. Now we need to subtract it from which equation? Equation number 2. What was equation number 2? This one. Al2SO4 whole thrice. Al2. So this was equation number 2. Al2SO4 whole thrice. On subtracting, this was giving 2Al3 plus 3SO4 2 minus. So on adding, we have got this equation, and we need to subtract it from equation 2. So when you will subtract these two equations, you can see very well that this 2Al3 plus and this 2Al3 plus, this 3SO4 2 minus and this 3SO4 2 minus will cancel out, and finally you will be left with what? You will be left with 3H2SO4 plus 2HCOO whole thrice Al giving you 6H plus 6HCOO minus plus this compound Al2SO4 whole thrice. So you can see the equation is also very well balanced, right? So this is how you will get the equation. Now you can easily see, now what is our aim? Our aim is to calculate the molar conductivity. So molar conductivity of equation 4, let's write down first of all molar conductivity of equation 4, which we have calculated here. So from here you can see the molar conductivity of equation 4 will be, since equation 4 was obtained by multiplying equation 1 with 3, we have obtained it. So its molar conductivity will be, equation 4 molar conductivity will be 3 times of molar conductivity of equation 1, right? And this we have multiplied. So the molar conductivity of equation 5 will be what? It will be 2 times of molar conductivity of equation 3, because we have multiplied the third equation by 2. So let's write down the molar conductivity of equation 4. So it will be 3 times of the molar conductivity of equation 1, which was 2x1. So finally you will write down 3 times of 2x1, which is 6x1, right? And the molar conductivity of equation 5 will be 2 times of, you will write down the molar conductivity of 2 times of the molar conductivity of equation 3, which is 3x3. So 2 times of 3x3, so you will write down 6x3. So this was the molar conductivity of equation 4 and 5. Now what we have done, we have added, so finally the molar conductivity of this equation we need to calculate. molar conductivity of this equation. Let's name it this equation as sixth equation. So the molar conductivity of the sixth equation can be written as, since sixth equation was obtained on adding the fourth and the fifth equation and then subtracting it with the second equation, so we will subtract the molar conductivity of the second equation. Finally, this was 6x1, this is 6x3, and the molar conductivity of second equation we have calculated, it was 6x2, right? So it will be 6x2. So finally the molar conductivity of this sixth equation will be 6x1 plus 6x3 minus 6x2. But here the molar conductivity is for 6H plus and 6HCO minus. How? Because in the equation we have obtained, but for what we need to calculate? We need to calculate on HCOOH. It on dissociation will give you 1H plus and 1 HCO minus. So for this we need to calculate the molar conductivity. But we have calculated the molar conductivity for how many? For 6H plus 6HCO minus, right? So what we need to do for the required equation, we need to divide the molar conductivity of sixth equation by 6. So your final answer will be the molar conductivity required for the required equation will be x1 minus x2 plus x3. So this is the molar conductivity of the required equation after dividing it by 6, since you required it for 1H plus and 1 HCO minus. So which option is correct? We will see that option C is correct answer, right? I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.